Hey, what did you think about the science lesson yesterday? That father and son did some pretty cool tricks, didn't they? With motion and force and gravity and friction and seeing all the different experiments. Really brings all those things we talked about to life. And it's more than just words on a science page. So I hope you enjoyed that. Today we're going to watch a digital lesson. And our essential question today is something you already know the answer to. What is motion? The answer is what? It's a change in position, right? We learned. So motion is a change in position. So we're going to look at a digital lesson today. So this is one of those where it reads to you some, and we'll do some things together. This is a little bit of a shorter one. So I'm going to be quiet and shrink myself, and let's get started.
Welcome to the lesson, What is Motion? In this lesson, we'll explore the concept of motion and how it affects an object's position and even an object's direction over a period of time. We'll also explore changes in the position of an object and how to calculate speed. The vocabulary words for this lesson are acceleration, force, motion, position, speed, and velocity. Click each word to learn more about it.
Well, I know we learned about these words in our lesson 2 days ago. So let's talk through these. We won't click on them. The first one we learned was position. It's an object's place relative to some other object that we use as a reference point. If it changes positions, we know that's motion, a change in position. Sometimes things can change position with a force acted on them, a push or a pull. And how fast it changed positions from one place to another is its speed, distance, and time. And then speed in a certain direction is velocity. So 50 miles an hour north is velocity because we added the direction. And then acceleration is any change in speed or velocity. So any change in how fast something's going, if it speeds up or slows down, or if it changes direction, is acceleration.
Did you know that right now you are in motion? Well, at least some parts of you are, like your eyes, your head, and inside your body, your lungs, and your heart. Anything that moves, whether it goes up, down, sideways, or just spins around, is in motion. Take a look around you. Can you see other things that are in motion? What type of motion do you think those items are in? Are they moving fast or slow, up or down, from side to side, or are they changing direction all the time?
What about you? What do you see in your surroundings that's in motion? I'm sitting, I can look over here to my left and I can look out my window and see cars going by, and they're going by fast. And from my perspective, they're going from side to side.
How fast do you think you were going on the way to school today? Did you know you can calculate how fast you were going by comparing the distance you traveled with the time it took you to get to school? This measurement of distance and time is speed. Let's see some examples of speed in everyday life. How about the numbers on the sign in the picture? Do you know what these mean? Click each of the pictures in turn to discover more.
All right, so if you saw this on the road and it said speed limit 25, what's 25 mean? It says it right here, doesn't it? You can go 25 miles per hour. Now, if you go 25 miles per hour in front of the school when the little traffic guard's out there, you might get a ticket because you're only supposed to go 20 miles per hour outside the school during school time in the mornings and afternoon. But those signs tell us the speed that we can go.
To make it easier to calculate speed, we use this formula. Speed equals distance divided by time. Next time you're in a car, see if you can tell what speed you are going from the speedometer.
All right. And then meters per second, that's that distance divided by time.
Speed can also be expressed in meters per second. This unit is often used to express the speed of runners. How many meters per second do you think you can run?
Not very many. I can't anyway. You could probably run faster than I can. I don't know. Meters per second. A meter's like 3 feet. I don't know if I could even run 2 meters per second. What do you think?
Look at these two school buses. How do you think their motions compare? Did you notice that they are moving in different directions? One bus is going to school in the morning, and the other is coming home in the afternoon. So the buses have different velocities. The velocity of an object tells two things: the speed and direction of the object. Two objects can have the same speed but different velocities because they're going in different directions. Click each image to see that bus's velocity. The bus coming home from school is moving south at 40 kilometers per hour, so it has a velocity of 40 kilometers per hour south. The bus on the way to school is moving north at 40 kilometers per hour, so it has a velocity of 40 kilometers per hour north. Same speed, different velocity. How do you think the velocity of a puck on an ice hockey rink changes as it moves around? Click the play button to begin. Once dropped, the puck is pulled to the ice by the force of gravity. Each hockey stick exerts a force that pushes the puck. Each time the puck is hit, its velocity changes. Even when it isn't hit, the puck slows down because the force of friction opposes its motion. The puck has acceleration whenever a force changes its velocity by changing its speed, its direction, or both. Do you remember how to calculate the speed of an object? Well, you've got to divide the distance traveled by the amount of time. What do you think is the speed of each of these objects? Drag the speed boxes to the correct locations.
Okay, so we got to divide the distance by the time. So this horse is going 24 kilometers in 2 hours. So what we've got to do is want to know how many it goes in every hour. So we've got to divide 24 by 2. Can you do that? Think about 2 times what would give me 24. If you said 12, you're right. Okay, where do I put it? Nope, I don't know where I put it. Am I wrong? 12 kilometers an hour? No, that's right. Down here? I don't know. Okay, 30 meters in 10 seconds. Right there. There we go. 30 meters in 10 seconds. Okay, 30 divided by 10. How many 10s are in 30? 3, right? So it would be 3 meters per second. There it is. 30 meters in 15 seconds, this bird flies. So 30 divided by 15. How many 15s are in 30? I think it's 2 or 1,200. There's 2. 2 times 15 is 30. The bird flies 2 meters per second. There's an airplane, or a jet rather, 3,600 kilometers in 3 hours. 3,600 divided by 3 is 1,200.
You got the speed calculations right.
All right.
Let's check and see if you can remember exactly what velocity describes. Click the option you think fits from the list below.
Velocity. I'm forgetting. Is it speed in kilometers, direction in degrees? I don't remember hearing anything about degrees. Do you? Speed and direction, distance and time. Well, we just did speed. Speed was distance and time, so I know it's not that. I know it's not degrees, so is it speed in kilometers or speed in direction? I think I learned that velocity was a speed in a certain direction, wasn't it?
That's right. The velocity of an object describes its speed and direction. Let's see if you can recall terms which describe acceleration. Select terms below which you think are correct, then click OK.
Well, acceleration is a change in speed. It could go faster. It could go slower. It's also a change in direction. It could change directions. So slowing down would be go slower. I think that's right. Sitting still, I don't think there's anything changing there if it's sitting still. Speeding up, I think, would be going faster, so it's accelerating. Turning around would be changing direction, so I think it would be that. I think it's those three.
That's correct. Acceleration is a change in speed or direction, or both. Something that is sitting still is definitely not accelerating, although when you sit still, parts of your body are still in motion. That's great work. Let's take a minute to review what you learned about motion. An object in motion constantly changes its position and sometimes changes its direction. The speed of a moving object is the distance the object travels divided by the time it takes to travel that distance. Velocity is the speed of a moving object and the direction the object moves. An external force is needed to change the motion of an object. Acceleration is the change in an object's velocity caused by a force acting on the object. Now that you've finished this lesson, if you wish, you can go back and review any part of the lesson again.
All right, so there's our same words we've been working with. Of course, we added gravity and friction to our list as well. So hopefully you're getting very familiar with these words now and that you're learning them better, and we'll be continuing to do some more assignments with them. Today, you do not have any assignment. I just wanted you to review this lesson with me, but we'll do another lesson tomorrow. So you can go and work on your other lessons now. Have a great day.